Hi everyone. In this module we discussed mass spectroscopy. Mass spectroscopy is in that organic chemistry part, third semester, Karnataka State Open University students. In this mass spectroscopy we discussed the basic introductions regarding to that mass spectroscopy, molecular ion or parent ion, some important features of the parent ion peak, nitrogen rule, determinations of molecular formula, McLafferty rearrangement, and metastable ions or peaks, importance of metastable peaks, nitrogen rules, retro drills order reactions. To discuss the important applications of this mass spectrum with different functional group. Here, mass spectroscopy is the most accurate method for determining the molecular mass of the compound and elemental composition. In this technique, the molecules are bombarded with a beam of energetic electrons. The molecules are ionized and broken up into many fragments, some of which are positive ions. Each kind of ions has a particular ratio of mass to charge. The mass spectrum means it is the record of the masses of the relative abundance of the molecular ion, the positively charged fragments formed from it by electron bombardment. The charge by M by A ratio are taken along the abscissa, while the relative abundance are taken along the ordinate. The base peak is highest peak or the most intense peaks in the spectrum. This is very important. The base peak is the highest peak, the most intense peak is the spectrum. The relative abundance of an ion means the percentage of the total ion current. In that, molecular ions are parent ion. The electron bombardment with energy 10 to 15 electron volt usually removes one electron from the molecule of the organic compound in the vapor phase. It results in the formation of the molecular ion. The highest occupied orbital of aromatic system and non-bonding electron orbitals on oxygen and nitrogen atoms readily lose one electron. For electron from double bond or triple bond is usually lost. Alkenes, the ionization of carbon-carbon sigma bond is easier than carbon-hydrogen bond. The mass of the parent ion gives the molecular mass of the sample. The mass spectrum, it is important to locate molecular ion high mass region of the spectrum. The stability of the parent ion decides the relative abundance. We have to find that what is the stability of these relative ions. Just you see here, this is this is molecule. It liberates electrons, what we are getting, M plus. This is benzene, liberations of this electron, parent ion. This alcohol liberates electrons, what we are getting, parent atom or ion. This is what, parent ion. The important features of the parent ion peak. The molecular ion peak ion aromatic compound is relatively much intense due to the presence of pi-electron system. The conjugated olefins show more intense molecular peak as compared to the corresponding non-conjugated olefins with the same number of unsaturation. Unsaturated compounds give more intense peak as compared to the saturated of the cyclic molecule. The relative abundance of the saturated hydrocarbon is more than the corresponding branched chain compound with the same number of carbon atoms. For example, the molecular ion peak for N-pentane is more intense than of neopentane. The substituents like OH, OR, NH2, etc., which lowers the ionization potential, increase the relative abundance in case of aromatic compounds. The absence of molecular ion peak in the mass spectrum means that the compound under the examination is highly branched or tertiary alcohol. In case of chloro or bromo compound, isotope peaks are also formed along with the molecular ion peak. In case of bromo compounds, M+ and M+2 peaks formed in the intensity ratio 1:1. In case of chloro compound, M+ and M++2 peaks are formed in the intensity ratio 1:3. What is the nitrogen rule? In that nitrogen rule, nitrogen containing compounds with an odd number, nitrogen atoms in the molecules must have an odd molecular mass. Even number of nitrogen atoms or absence of nitrogen atoms in the compound show that the molecular mass of the compound must be even. This is the nitrogen rule. We consider a simple example for that. Here, to explain the nitrogen rule, let us consider nitrobenzene. In that nitrobenzene C6H5NO2, the signal for molecular ion appears at M/E 123. Odd numbered molecular mass since the compound contains only one nitrogen atom. Two important ion fragments which are formed in the mass spectrum of these compounds are NO2 at M/E 46, NO plus at M/E 40. Both these fragment ions appears at even mass number. We consider another one example according to that nitrogen rule. Nitrogen to nitrogen atom say 2,4-dinitrophenol. Its molecular ion M plus signal appears at 184. The fragments ions appear at M plus minus H here 183 and M plus H CO at 155. Thus, we see that fragment ions containing both the nitrogen atoms appears at odd mass number. This proves validity of that nitrogen rules. Here, how we are getting this 120 or this one 123 is there. How we are getting? Just we consider here 6 into 12 is the atomic mass of carbon, hydrogen 1 into 5 hydrogen plus nitrogen 1 into 14 nitrogen plus oxygen 2 into 16 oxygen. What we are getting here 123. That is mass peak. Just we are going to add atomic mass of the elements. What we are getting molecular mass. How to determine the molecular formula? The molecular formula is determined with the help of mass spectrum. It's a plot representing M/E values of the various ions against their corresponding relative abundance. The peak on the extremely right corresponds to the molecular mass of the original molecule. In case of straight chain hydrocarbon, the abundance of the parent ion peak is fair. It also gives M plus 1 peak, which is appear 9.9% abundance compared to the 99% compared to the parent peak. Consider the peak at M/E values here 100, 85, 71 and 43 etc. It clear that straight chain alkenes because fragments are formed 14 units apart. 14 units apart means here carbon 14. Carbon 14 and hydrogen 28. What we are getting here 100. Okay. And to breaking of this bond, what we are getting here, to breaking of each bond, here 85, 71, 53, 43, etc. In case of straight chain hydrocarbon, a peak due to C3H7 is most abundant. C3H7 is most abundant peak. C3H7 means what here? 12 into 3 plus 7 into 1. What we are getting here? 43. 43 is the most abundant peak. The molecular formation of the compound can be octyl. In case of an organic compound gives fragment as well as parent peaks in pair which are 2 apart. Then if the pair peaks or intensity ratio is 1:3, then it must be fluorocompound. Here, if the pair peaks appears in the intensity ratio 1:1, it must be bromocompound. Okay. Just we consider the determinations of this molecule. Here C14H Cn H2n + 2. Here H2n means 28 plus 2, 30. C14H30. In that C14, 14 into 12. 14 into 12 plus 30 into 2. 30 into 1. Okay. This is what the 14 units apart like that. Let us determine the molecular formula of the compound in the mass spectrum. What they are given here. Ethyl bromide molecules. The molecular mass of ethyl bromide is what? 110. Here 2 remove of the 2 electrons. Here what we are getting here? 108. As the pair of peaks are equally intensity, it is a bromo compound. The isotopes of bromines are Br79 and 81. The pair of extreme right compounds to M+ and M+2 peaks. The spectrum corresponds to the molecular formula C2H5Br. In some cases, McLafferty rearrangement ion peak gives an important clue in the determinations of molecular formula of the compound. For example, all straight chains aldehydes containing gamma hydrogen atoms form a base peak at M/E44. Also, aldehydes fairly abundant M+ peaks follows a less abundant M+-1 peak. Let us consider a simple mass spectrum having M/E values at 72, 71, 44, 43, 29, etc. Here, a single at M/E44 is due to McLafferty rearrangement ion. This shows that it is a straight chain aldehyde as M+ peak at 72 also accompanies M+-1 peak at 71. Hence, the formula of the compound is C3CH2CH2CH2. This McLafferty rearrangement is very important in the point of examination in mass spectroscopy. The statement is involves the migration of gamma electron. This is what? Alpha. This is beta. This is gamma. Involves the migration of gamma hydrogen atom followed by the cleavage of a beta bond. The rearrangement leads to the eliminations of neutral molecules from aldehydes, ketone, amines, unsaturated compound, substituted aromatic compound, etc. The rearrangement proceeds through a sterically hindered 6-membered transition state. Okay. Here gamma hydrogen atom is migrated. What happened to breaking of this bond? Here CH2 double bond C single bond OH R. This is what? Compound McLafferty ions. The butanol contains gamma hydrogen atom. The McLafferty rearrangement ions formed in this case is below. This alpha, beta, gamma hydrogen atom is migrations. Here what happened here? CH2 double bond C OH H. Here CH2 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 CH2. Similarly, a large number of organic compounds like ketone, amines, alcohol, esters, acids which contain gamma hydrogen atoms form a McLafferty rearrangement ions. Thus, molecular formula of the unknown compound can be determined from the various fragment ions and also parent ions of the mass spectrum. What is the metastable ions or peaks? Metastable peaks can be easily determined in a mass spectrum. Some important characteristics of these peaks are they do not necessarily occur at the integral MIE values. These are much broader than the normal peaks. These are relatively low abundance. The importance of metastable peaks. The metastable peaks in the mass spectrum greatly contributes in structural elucidation. From the position of the parent ion, the daughter ion, the position of the metastable ions calculated as above. This confirms the spectrum under examination. Consider the spectrum of toluene. The formation of less intense metastable peak at 46.6 leads way to the structure of toluene. It is due to the fragmentations of C7, H7 to C5, H5 ion in the second field free region. Similarly, in the presence of metastable peaks at the expected positions of the suspected compounds lends weight to its structure. The most likely reasons for the broadening of the metastable peak is the possibility that some of the excitations energy leading to bond capture may be converted into additional kinetic energy. What is the general fragmentations modes? The relative abundance of the fragment ions formed depends upon the stability of the ions, also stability of the radical lost. The stability of the ions can be judged by the stabilization of the charge, depends upon the resonance, inductive effect and polarizability and so on. The radical site is relative and can form a new bond. The formation of new bond is powerful driving force for ion decomposition. The energy releasing during bond formation is available for the cleavage of some other bonds. Just we discussed some important fragmentations modes here. The simple cleavage and homolytic cleavage. The process involves homolytic or heterolytic cleavage of a single covalent bond. The homolytic cleavage is initiated by radical side. Odd electrons and unpaired which capable of new bond formation. When a bond is formed, energy is released. The energy bond formation can help offset the energy required for the cleavage of some other bond and the ion. Homolytic cleavage reactions are very common and can be classed in the following modes. That mode 1, fragmentation. In that mode 1 fragmentations here, which heteroatom is singly bonded to carbon atom. Heteroatom is singly bonded to carbon atom. Parent ion is formed by the removal of one electron from the heteroatom. A new bond is formed with the adjacent atom through the donation of the unpaired electron and the transfer of electron from the adjacent bond. The most abundant peaks are formed by the cleavage of carbon-carbon bond, which is in the alpha position of heteroatom in the mass spectrum of alcohols, amines, ethers. The mass spectrum of 3 isomeric butyl alcohols are different. The secondary and tertiary butanols undergo this type of simple cleavage. N-butanol undergo eliminations to give a peak at MIE values. Here what happened here? That alcohol to cleavage this or CH double bond OH. Here also to breaking of this or CH to O. Here double bond, here all dash to cleavage of this bond. In amines molecule is also to cleavage of this bond. To cleavage of this bond, what we are getting here or CHNH R. the cleavage, consider the cleavage in 2-butanol and 2-methyl-butanol. 2-butanol means here, this is carbon position 1, 2, 3, 4. 2-butanol to cleavage of the CH3 molecule. What we are getting here? CH3, CH, CH2, OH molecule. What is that? M by E 59. That tertiary alcohol to cleavage of this CH3, CCH3OH plus removal of that CH3 molecule, M by E is equal to 59. Just you are going to count it down that mass here. How many? Carbon 1, 2, 3. 3 carbon. 36. 12 into 3. Next, how many hydrogen? 3 plus 2, 5. 5 plus 1, 6. 6 plus 1, 7. Hydrogen, 7. Oxygen, 16. Totally what? 59. Totally what we are getting here? 59. Like that you are going to calculate that. In that mode 2 operation, when a heteroatom is attached to a carbon atom by a double bond, alpha cleavage is preferred, fragmentations mode. This type of fragmentation is shown by many compounds such as ketones, esters, amides. Compounds containing carbon nitrogen and carbon sulfide groups do not show this type of fragmentation. Okay. In case of ketones, the significant peaks are observed due to cleavage of carbon-carbon bond, which is alpha to the carbonyl group. That unsymmetrical ketones shows two types of peaks since either alkyl group can be lost. The eliminations of a bigger alkyl radical is preferred in some way of the fragmentation mode in aldehydes, esters and amides leads to the cleavage of CH, CO and CN bond respectively. In that mode 3 fragmentation, here benzoyl cleavage is an energetically preferred fragmentation mode. It involves the cleavage of carbon-carbon bond which is beta to the aromatic ring. Here, this is what? To remove this molecule, what we are getting, this carbon 6 is there. Again, this is joining into the formation of what? Tropium. Considerable stabilization of tropylium cation is provided by the aromatic system. Thus, mass spectrum of ethyl benzene is very intense. In heterolytic cleavage, it may be noted the cleavage of CX bond is more difficult than of a CC bond. In such a cleavage, the position charge is carried by the carbon atom, not by the hetero atom. It can show fragmentations of alkyl halide. These are all different examples. Please we go through that. The retro Diels order reaction. The retro Diels order reaction. This reaction is an example of multi-centered fragmentation, which is characteristics of cyclic olefins. It involves the cleavage of two bonds of a cyclic system, resulting in the formation of two stable unsaturated fragments in which two new bonds are formed. This process is not accompanied by any hydrogen transfer rearrangement. The charge can be carried by any one of the fragments. The most highly substituted or more conjugated fragments which has lower ionization potential carries the charge. This is the molecule. To remove that electron, it becomes what? Positive charge. To cleavage of this bond here CH2, CH2. Here what it is there? CH2 is there. Here CH2 is there. The final fragmentation comes like that. Hydrogen transformations rearrangement. The simplest rearrangement involves the transfer of a hydrogen atoms from one part of the molecule to another. These processes are very common in mass spectroscopy. This involves intramolecular hydrogen transfer rearrangement in aliphatic hydrocarbon and aromatic compounds. Rearrangement involves the Migrations of groups heavier their hydrogen are called skeletal rearrangement process. Consider hydrogen transfer from the ortho position in benzoic acid prior to fragmentation. This is what benzoic acid. This hydrogen is shifted to here. What happened here? This is called what? Fragmentations. The hydrogen transfer rearrangement, generally a 6-membered transition state is formed, but other transition state is also common. So what happened here? Just to see, this hydrogen is removed here. This halogen HX. What happened here? CH2 to formation of that what? Cyclic elimination. The elimination reaction operates only from the molecular ion but also the fragment ion. The positive charge generally remains on the carbon containing fragment. Alcohol usually eliminate a molecule of water from the molecular ion. Consider an example. N-butyl and N-pentyl chlorides undergo hydrogen chloride eliminations by the abstractions of alpha hydrogen atom by 1,3 mechanisms. That eliminations of ketone CH2CO is a characteristic fragmentation mode of N-alkyl amides and orthoacetal and phenols. Just you see here, two migrations of this hydrogen. What we are getting here, this is to breaking of this bond C double bond O CH2 CH, like that. Is also to breaking of this bond, because this oxygen is gaining of this. What happened? Here is also N is gaining of this hydrogen. What happened here? CH2 C double bond O. Ortho substituted ortho compounds or in cis olefins, the substituents and a hydrogen atoms can come in close proximity so as to eliminate a neutral molecule. This is what ortho positions, that ortho positions to cleavage of this, like that you are going to read that. Here double bond is there, here single bond is converted into C double bond. Here also to eliminate this water molecule. Here is also to remove of this molecule what we are getting this product. Such elimination distinguish between cis and trans isomer, ortho disubstituted compound from meta and para substituted isomers. What is the mass spectrum of hydrogen? Some important features we mentioned here. Mass spectrum of hydrogen. What are the some important features of this alkenes molecule? That alkenes relative height of the peak decreases as the molecular mass increases. The group peak of the mass spectrum observed 14 mass units apart. The most abundant peak corresponds to HCN H2N plus 1. The most intense peaks are due to C3 and C4. Here C3 means 43, C4 means 57 respectively. There is no preferred charge stabilization site favors any specific cleavage. The peak corresponds to CnH2n ions accompanied by CnH2n and CnH2n ions must be less abundance. The order they are going to mention here, allylic is greater than tertiary, greater than secondary, primary and methanol. The stability of the free radical lost depends upon the length of the straight chain, since it allows greater dispersal of the odd electron. Greater the dispersal of odd electron, greater is the stability of the free radical. Consider example, N-butyl free radical is more stable than N-profile free radical. Okay. The nature of free radical, whether primary, secondary or tertiary. The mass spectrum of dodecane. Here, the C4H9 is the base peak is due to the formation of the most stable secondary carbocation. Already ಹೇಳಿದ್ವಿ ನಾವು ಹೈಡ್ರೋಕಾರ್ಬನ್ಸ್ ಅಥವಾ ಆಲ್ಕೇನ್ಸ್ ಅಲ್ಲಿ ಮೋಸ್ಟ್ ಸ್ಟೇಬಲ್ ಪೀಕ್ ಯಾವುದು ಅಂದ್ರೆ C4H9 ಮತ್ತೆ ಯಾವುದಿದೆ C3H7. ಅದರ ಪ್ರಕಾರ ಮಾಡ್ತಾ ಇದೀವಿ. C3H7 is much abundant for some reasons. Okay, just you see this C4H700 first breaking of this bond and C3 to breaking of this bond like that. Okay, the relative abundance goes on decreasing from M by E 57 to 71 to 85 and so on. As expected, the molecular ion peak is much less intense. Also, we notice small peaks for Cn H2n-1 and Cn H2n ions. The M plus and M plus plus 1 peaks are formed at M by E 128 and 129. The other signals which appears in the spectrum are M by E 43, 57, 71, 85, 89, 99, etc. along with their less intense peaks. Next molecule we are going to take on this alkenes. That alkenes molecule, the molecular peak in the spectra of unsaturated compound is more intense than corresponding saturated homologous. The reason is the better resonance stabilization of the charge on the cation formed by the removal of one of the pi electron. The monoolefins containing CnH2n-1 ions in their mass spectra. Here is also 14 mass units apart to breaking. In that alkenes, CnH2n ions formed by McLafferty rearrangement are more intense. For example, McLafferty rearrangement ion is formed at M by E 42 from 120 due to loss of ethylene molecule. Here, this molecule is what? M by E value is 42 because here 3 carbon atom is there plus 6 hydrogen atoms. 6 hydrogen atoms. 36 plus 6. Here, what is that? 42. In acetylene molecules or in that alkynes molecule, 1 butane and 2 butane, the molecular peak is the base peak. The relative abundance of the molecular ion peak decreases as the molecular mass of the alkyne increases. In alkynes, the fragment ions are generally formed by the loss of alkyl radical. Here to removal of that 15, 29, etc. 15 means what? Here CH3, 29 means CH3, CH2 like that. Okay. That cycloalkanes, the important characteristics of the mass spectrum of cycloalkanes, what are those? The relative abundance of the molecular ion of cycloalkane is more as compared to the corresponding alkane. It favors cleavage at the bond connecting the ring to the rest of the molecule. Fragmentation of the ring is usually characterized by the loss of 2 carbon atom as C2H4 and C2H5. The stability of the fragment ion depends upon the size of the ring. The fragment ions are commonly observed by the loss of alkenes or alkenyl ions. The side chain on the ring breaks and the lone and odd electrons remains the ring. The peak at M by E 128, the molecular ion peak is quite abundant. The largest peak is 83. For this what molecules like that N-propyl cyclohexene molecule. As it is, you are going to study that. Okay. That ion radical shows retro Diels order reaction. A fragment ion is formed at M by E 55. Here this is what? N-propyl benzene. Here first 2 cleavage of this bond and it is having only benzene plus, that is 83. This is what? M by E 55. In cycloalkenes and cycloalkynes molecule. That cycloalkynes molecule, the double bond in the acyclic ring introduces a possible pathway involving retro Diels order reaction. We are going to take an example of the cyclohexene molecule. In that cyclohexene molecules, we are getting different possible mass spectra are mentioned. In cyclic olefins, usually show distinct molecules like the a unique mode of cleavage is a type of retro Diels order reaction. The retro-diel reaction is an example of a multi-centered fragmentation mode, which is characteristics of cycloolithanes. This is the example of this one, cyclohexene molecule. To liberations of these electrons, what we are getting here, plus and radical. To migration of this bond, what we are getting, CH2 plus CH2, CH2 plus CH2. The mass spectrum of cyclohexene, the peak at M by A 54, is formed in fairly high abundance. The path formation seems more viable because the ions resonance stabilities. The radical and positive charge are stabilized by resonance, forming a peak at M by E 54, which is intense. Some important features of this aromatic compound. In that aromatic compound, the molecular ion peak in aromatic compound is fairly abundant as compared to the corresponding alkanes and alkenes containing the same number of atoms. The aromatic compound M plus 1, M plus 2 are also noticed. The reason is fairly large abundance of the molecular ion peak. In case of polynuclear hydrocarbon, doubly or triply charged ions are possibly formed. Doubly charged molecular ion appear at integral M by E values. If the aromatic ring is substituted by an alkyl group, a prominent peak is formed at M by E 91. Here benzoyl cation formed rearranged to tropylium cation. The fragmentation patterns of N-propyl benzene is given below. This is what N-propyl benzene molecule. To cleavage of this molecule, what we are getting, benzene plus CH2. This is benzyl cation. Benzyl cation it undergo to formation of that tropylium. This is called what? Tropylium ion. Next, again to loss of this CH2, C2H2, what we are getting M by E 61. Here just you go to that. The benzyl cation is formed, rearranged to more stable tropylium cation, which appears at M by E 91. Tropylium cation in turn loses a molecule of acetylene from C2C5H5 at M by E 65. The cleavage of a carbon-carbon bond, which is in the beta position of the aromatic ring, is an energetically favored fragmentation mode. To remove of this, what we are getting, tropylium cation. The mass spectrum of ethyl benzene has a M plus CH3 peak in large abundance. The fragment ion appears at M by E 91 and it is base peak. Tropylium cation then loses a molecule of acetylene, that is 26 mass units, to form a peak at M by E 65. The mass spectrum of ethyl benzene are mentioned here. The mass spectrum of ethyl benzene. The various fragmentation modes of N-butyl benzene. First, the cleavage of this molecule. Here, CH2, CH3, that is removed. Here, CH2, H is there, and it undergo tropylium and cyclopentanyl bond. Next, we discuss some important features of mass spectrum of alcohol. What are the important features? The molecular ion peak of primary and secondary alcohol is usually of low abundance. It is not detected in tertiary alcohol. The parent ion peak is formed by the removal of one electron from the lone pairs on the oxygen atom of primary and secondary alcohol. The number of fragmentation modes in alcohol depends upon the fact whether it is primary, secondary or tertiary alcohol. The fragmentations of carbon-carbon bond adjacent to carbon atom in alpha cleavage is the preferred fragmentation mode. The single at M by E 31 appears in large abundance in the mass spectrum of methanol and other aliphatic primary alcohol. The signal corresponds to the formation of oxonium ion. Oxonium means CH2OH is formed by the cleavage of carbon hydrogen bond in methanol. Here methanol is there. What happened here? CH2CH. Here 1 to removal of this CH2OH. Primary alcohol show M18 peaks corresponds to loss of water. The primary alcohols having a chains of 4 or more carbon atoms show a peak which corresponds to M plus 18. It can show mechanically as follows. This is what alcohols to breaking of this bond as it is like that here. To cleavage, what we are getting H2O in what we are getting here like that. This is plus, this is minus. Okay. Long chain members, any show peaks corresponds to successive loss of hydrogen radical at M-1, M-2, M-3. It can be represented as shown. The CH2 double bond OH is most significant peak in spectra of primary alcohol. In that secondary alcohols, the cleavage to give prominent peaks due to 45, 59, 73. Tertiary alcohol fragment to give prominent peaks or 59, 73, 87. In addition to the alpha cleavage, primary alcohol also undergo beta, gamma, delta cleavage to form peaks at M/E 45, 59, 70. This is various fragmentations as shown in that figure. In that cyclic alcohols, the fragmentation patterns are quite complicated. In case of cyclohexanol, molecular ion peak appears at M/E 100. It loses a hydrogen radical to form M plus minus 1 peak at M/E 99. Thus, in turn, loses a molecule of water from form a signal at M plus H2O at 81. In allyl alcohol, ion is formed due to its high stability. In that McLafferty rearrangement, ion peak as also reported in that molecule. In aromatic compounds, in aromatic alcohol, some important features of mass spectra of aromatic alcohols are relative abundance of parent ion of aromatic alcohol is fairly large. Some of the fragment modes of benzyl alcohols are loss of 1, 2 or 3 hydrogen atom. The fragment ion MH further elimination CHO radical. The MH fragment of benzyl alcohol also rearranged to form hydroxyl tropylium ions. This is what hydroxyl tropylium ions. This is. For example, mass spectrum of 1-phenyl ethanol are mentioned here. The base peak corresponds to the eliminations of methyl radical, the peak at 107. The base peak and represents the hydroxyl tropylium ion. Hydroxyl tropylium ion further loses a molecule of carbon monoxide to get ion fragment at M/E 79. Its relative abundance is fairly large. That unsaturated alcohol means that is allylic alcohol, that is what unsaturated alcohol. Consider the mass spectrum of cyclohexanol. The base peak in this case formed at 57. The molecular ion peak is of low abundance. The loss of water molecules produces an ion radical M/E 82 is fairly abundant. In that example, cyclohexanol are mentioned here. The various fragmentation modes are represented or shown here. Phenols, some important features of the mass spectrum of phenols. The molecular ion peak M plus is intense. The peak due to loss of hydrogen radical M plus H is small. The fragment ion is due to loss of carbon monoxide is most significant, is less intense than M28. The results from very intense MH peak due to the formation of hydroxytropylium ion. The catechol peak is intense while M28 and M29 ions are formed in abundance isocyanates and phenol. This is the fragmentation mode of this phenols molecule. The first two here, this is the second step, this is the third step. Okay, that pi electron is migrated to removal of that H is attacking here. Removal of CO, what we are getting? Removal of CO, what we are getting? 5 member. And removal of pi electrons, what we are getting? 60. Consider the fragmentation modes in that paraprism. Paraprisms means here CH3OH both are present, that is called what? Paraprism. That paraprism, to removal of that hydrogen, what we are getting? This one, this one. In general, we have to write that tropylium hydroxide. Thiols and thiophenols. In that thiols, some important features. The molecular ion peak in thiol is more intense than in alcohol. Like alcohols, they undergo alpha cleavage, leading to the formation of ions in the series M by E, 47, 61, 75, etc. Like alcohol, the elimination of H2S in thiols is less important. They involve the transfer of hydrogen atoms from the third or fourth carbon atoms down the chains to sulfur hydrogen. A transfer from the fourth carbon is more likely as it involves the 6-membered ring intermediates. The thiols with 5 or more carbon atoms lose ethylene and H2S concerted the steps to form. Here MCH2 double bond CH2 plus H2S ions consider mass spectrum of pentane 1 thiol. This is the spectrum of this 110 mass spectrum of pentane 1 thiol. In this case, the molecular ion peak is formed at M by E 104. The ion at M by E 47 is result of alpha cleavage. It also indicates that thiols is primary. The peak at M by E 61 is due to an ion containing sulfur, indicating the presence of the following structure units. This is the cleavage of this bond here. It happens CH3, CH2, CH2, here CH2, CH2, sulfur. A base peak results due to the loss of ethane and H2S. That thiophenols, just I list out that some important feature. Thiophenol shows intense peak at 110. The various ions formed during formation include MH, MCH, triple bond CH, MSH or MCS, etc. The loss of hydrogen from the molecular ion to gives thiotropylium ion, which then less CS to form an ion M by E 65. That ethers and acetols and ketones, that aliphatic ethers, the presence of oxygen atoms in ethers can be shown from strong peaks at 31, 45, 59, etc. Okay, this is what N-pentyl ether, the spectrum of N-pentyl ether. What are the greatest peak here? The peaks are 31, 45, 59. 31, 45, 59. The various fragmentation modes are written here. The various fragmentation modes of this molecule are written here. What is that molecule? N-pentyl ether are written here. In aryl ethers means that is the aromatic ethers. The molecular ion peak is fairly abundant. Methyl phenyl ethers show two main fragmentation. Primary fissions occurs at bond to the during loss of methyl gives an ion M15. It further split to two loose carbon monoxide. The fragmentation patterns is shown in that here. This generally we have to return like that to breaking of this bond FCH2 CHR to the thioethers. The molecular ion peak of thioethers are more intense than aliphatic ethers. Alpha cleavage of CS bond with positive charge on sulfur is the favored mode of fragmentation. The smallest alkyl chains is lost compared to the usually behavior in the bigger chain lost. The beta cleavage of bond CH or CH gives rise to peak 46, 61, 75, 89, etc. This is the fragmentation patterns of the mass spectrum of secondary butyl ethyl ether. In aliphatic aldehydes and ketone. Here in aliphatic carbonyl compounds, here the intensity of the molecular ion peak decreases as the alkyl chain increases. The majority fragmentation processes alpha and beta cleavage. The alpha cleavage, the bigger group on either side of the carbonyl group is preferably lost. Next, in aldehydes and ketones containing gamma hydrogen atom, McLafferty rearrangement is the most intense, significant in an aldehyde which is not alpha substituted Fe to this form. M by E 44 may be base 2. In McLafferty rearrangement, ions in methyl ketones which are not alpha substituted appears at M by E 58, which is quite abundant. Lower aldehydes alpha cleavage is prominent with reactions of charge on oxygen. Aldehydes methyl or alkyl radical is preferably lost compound to hydrogen radical. Consider the various fragmentation modes of pentanol. This is what pentanol, the various fragmentation modes of pentanol are. Here this is what M by E 86 to alpha cleavage it undergo what we are getting M by E 27, M by E 57 and 44, etc. So the example they mentioned in that. The fragmentations and draw for that mass spectrum 3 hexanone, that is ketones, aromatic aldehydes and ketone. This compound's parent ion is intense. M1, M28 due to elimination of CO in benzaldehyde are formed. Peak at M by E 77 due to C16H5 followed by the 1 at M by E 51 due to C4H3. As a result, consider benzaldehyde. That cyclic ketones molecule. Some important features of the cyclic ketones are the molecular ion peak of cyclic ketones is quite intense. The base peak in cyclopentanone or cyclohexanone is formed by alpha cleavage followed by hydrogen transfer rearrangement. The peak due to CH2 double bond CH CO is formed by what? 55. The peaks are formed by the loss of ethyl in carbon monoxide molecule in pair abundance in case of cyclohexanone. This is the structure of the cyclohexanone molecule. The mechanisms are written here like that. That aliphatic and aromatic acids, that aliphatic acid, some important features of mass spectra. The molecular ion peak in aliphatic acid is less intense as compared to the aromatic acids. The cyclic group is directly eliminated by alpha cleavage and a signal is formed at 45. Alpha carbon is not substituted in aliphatic acids containing a alpha hydrogen atom. A McLafferty rearrangement ion is formed at M by E 60. It is often a base free. The short chain acids MOH, MCOH peaks are prominent. The various fragmentation modes in butanoic acids are mentioned here. This butanoic acid, first to cleavage of the COOH, like that. Consider the mass spectrum of this pentanoic acid mentioned here. Please we go through that. That aromatic acids. That aromatic acids means benzene with containing COOH group. Here is also here M by E 122, here 107, 79 and M by E 51. Consider the various fragmentation modes in benzoic acid. In benzoic acid, M plus OH peak is quite prominent. It is followed by another peak due to the loss of CO molecule. It appears at M by E 57. This in turn loss of molecule of acetylene. That esters molecule. The important features of these esters molecules are mentioned here. The molecular ion peak is weak. The fragmentations, the fragment ions due to alpha cleavage is usually observed. The methyl esters peaks due to RCO, R plus, CH2O plus and C3OCO are observed. The methyl esters are not substituted at the alpha carbon, show McLafferty rearrangement ion at M by E7. Methyl substitutions at the carbon atom shift the position of McLafferty rearrangement ion peak. The various fragmentation modes of methyl butanoate are shown in that. The molecular ion peak is comparatively more intense. The benzyl acetates and alkyl acetates eliminates neutral ketene molecule to form a base free. This is the structure of this 1-propyl butanoate. It can be distinguished from methyl butanoate by a peak at 61. It is due to McLafferty rearrangement ion. The esters of groups are mentioned here, aromatic esters. That amides. Some important features of the mass spectra of aliphatic amides are the molecular ion peak of straight chains monoamides is usually discriminable. The McLafferty rearrangement peak in amide is usually the base peak. The McLafferty rearrangement ion appears at M by 59. Primary amides give a strong peak at 44 due to NH2CO. The moderate peak at M by 86 results from gamma carbon atom alpha cleavage, possibly accompanied by cyclization. When N-alkyl groups C2 are longer and the acyl moiety is shorter than C3, another mode of cleavage predominates. This is the cleavage of the N-alkyl groups beta to the nitrogen atom and cleavage of the CN bond with migrations of an alpha hydrogen atom of the acyl moiety. Just you see that here what happened to removal of that molecules to migrations of these pi electrons, the migrations of these electrons, what we are getting amides molecule. That aromatic amides, in aromatic amides the parent or molecular ion peak is relatively intense. The primary fragmentation mode from an aryl cation, which in turn loses molecule of carbon monoxide. This is the spectrum of benzamide. The molecular ion peak is observed in that 129. Benzyl cation peak observed in that 105. Further loss of CO form another peak at M by E 77 due to C6H5 ion, which in turn loses a molecule of acetylene. Some important features of mass spectra of allergen compounds are mentioned here. The molecular ion abundance of a particular alkyl halide increases. as the electronegativity of the halogen substituent decreases. The relative abundance of the molecular ion decreases with increase in chain length and increase in branching. Compounds containing chloride, bromide show characteristics isotopics. A compound containing one chlorine atom show M plus to peak, which is 1/3 in intensity of parent peak. Monobromo compound shows peak which is of the same intensity compared to parent peak. The parent ion charge resides on the halogen atom. Important fragmentation mode is alpha cleavage with the charge retention by the halogen retaining fragment. Another mode leads to loss of allied radical. Here, to breaking of this, here CH2 double bond. Okay, to breaking, what we are getting are CH2 H preferable bond. That amines molecule. That aliphatic amines molecule, some important features are discussed here. If the molecular ion is formed at the odd mass number, then molecules carries number of nitrogen atoms. The molecular ion peak in monoamines is formed in very small abundance and is undetectable in long chain or branch chain amines. For primary amines, the base peak is formed at M/A30 due to CH2 double bond NH2. It results form the molecular ion in alpha cleavage. Higher the homologous of amines may appear at 44 and 58 etc. but their relative abundance is much less. The parent ion may lose an alkene to form fragment ion M plus CnH2n. The loss of largest branch from the alpha carbon atom is preferred. Just to see here R2, just to see here R2 that is shifted here to breaking of this, to formation of this pi bond here. What happened R1, R1, R3, R4. That is R2 is eliminated like that. Here, the higher aliphatic alkyl amines beta cleavage is not very significant. The alpha cleavage is sometimes preferred. Consider example of this mass spectrum of ethyl amine. The various signals along with their relative abundance are shown in that figure. This is what ethyl amines molecule. That ethyl amines molecule, that is the value of this. The molecular ion peak appears at 45. The alpha cleavage results in the formation of a base peak at M/E30. The parent ion loses a hydrogen radical. The various fragmentation modes are given below. This is what M/E45. CH3, CH2, NH2. Here, one CH3 is removed. What we are getting? CH2 double bond NH2. Again, that shifting of this hydrogen from that amine group. Then what is that? 40. In amines, a hydrogen radical is lost from the parent ion to give M plus -1 peak. In higher aliphatic amines, beta cleavage is not very significant. Gamma cleavage is sometimes preferred. A peak at M/E30 is good, but not the conclusive evidence for the strength of chain primary amine. The fragmentations of the parent ion formed from secondary and tertiary amines leads to peak at M/E30, 44, 58, 72. The aromatic amines, a parent ion is formed by the loss of one electron from the lone pair present on the nitrogen atom. The elimination of hydrogen radical and HCN molecule are very common from the parent ion. Thus, in primary aromatic amines, M+-1, M+-27 signals are often observed. The eliminations of 27 mass units give a single due to cyclopentadienyl cation. For N alkyl amines, alpha cleavage of the alkyl group is common. This is the structure of this aniline molecule. That aniline molecule, the different fragmentation modes are mentioned here. Initially 92, removal of H, what we are getting here, NH2, we are going to add HCN here, H here by E 66, finally, what is that by E 65. That nitro compounds. The important features of mass spectra of nitro compounds are mentioned here. The molecular ion peak in aliphatic nitro compounds is usually absent, but it is prominent in aromatic compounds. Aliphatic compound, the signals due to NO plus and NO2 are usually observed. In aromatic nitro compounds, the signals for NO plus, NO2, MNO, MO2 are commonly observed. If a hydrogen containing group is also present ortho to the nitro group, then MOH peak is also observed. For aromatic nitro compounds, the molecular ion peak appears at odd mass number for one nitrogen atom and is fairly strong. Also, strong characteristic peaks are observed by the eliminations of nitro and also nitrosonium radical. It's a last forming phenoxycation. Just you see here, it's a nitrobenzene rearrangement is going on. In that rearrangement, to remove of that NO molecule, what we are getting, benzene with oxygen here, M by E 65. When a substituent is present in meta and para position, the fragment modes are similar to those as observed in that nitrobenzene. But when the substituent is present in the ortho position, then it interacts with nitro groups as follows. Here 137, to removal of HO, what we are getting 130, again removal of NO, here M by E 92. Just we are going to calculate that M by E is 92. How we are getting? Initially I told you here 12.6, 72. Here 1 into 6 and 1 into 14. 1 nitrogen. 1 into 14. Here 8, 12. Here 19. Like. Similarly, consider the fragmentations of ortho nitro aniline. In that ortho position, aniline is there, that amine is there, ortho nitro aniline. Here it is having to formation of this OH, and remaining is there benzene, NO, here NH. In aliphatic nitriles molecules, some important features of the mass spectra of aliphatic nitriles. The molecular ion peak of aliphatic nitrile is weak or may be absent. This is the cleavage of this, here NH, gaining of this proton. NH, see this one. To breaking this, what we are getting, NH, C, CH2. M by E is 41. A weak but diagonistically useful M-1 peak is formed by the loss of alpha hydrogen atom to form stable ion. The base peak of straight chain nitriles between C4 and C9 is 41. This peak is due to the ions resulting from hydrogen rearrangement in 6-membered transition state. The peak at M/A 97 is characteristics and intense in straight chains nitrile C8 and higher. The following mechanisms are suggested here. What happened here? This is to breaking of this bond here NH to gaining of this NH molecule. What we are getting here, this is what the concept of this what amines molecule is the concept of aliphatic nitriles molecule. Okay. Finally, to summarize this unit, the important features of this mass spectroscopy are: mass spectrometer gives a record of the relative abundance of ions according to the M/A ratio. Molecular ion peak is not generally visible in case of alcohol. A peak corresponds to the ions of maximum abundance is called base peak. The molecular ion or the parent ion peak may or may not have the base peak. Usually it is not. Molecular ion has usually the highest M/A value in the spectrum, and its M/A value is equal to the molecular mass of the compound. The molecular ion is usually not much stable and tends to fragment. The fragmentations of molecular ion produce daughter ions of definite M/A value, which helps in structure determination. The McLafferty rearrangement on alkane molecule is lost in a cyclic rearrangement with gamma hydrogen. The intensity of M+1 peaks is valuable to know the number of carbon atoms as well as nitrogen atom. In case of nitrogen is absent, the number of carbon atoms can be calculated by dividing the relative intensities of M+1 peak by 1. The typical case of M+2 peak of the parent ion looks larger than the M+1 peak. The compound may contain sulfur, chlorine or bromine atoms. If a compound contains chlorine atom, then pair of peaks are obtained at 2 mass units apart in the intensity ratio 1:3. But in case of bromine atom is present, then pair of peaks at 2 masses of unit apart are the equal peak. The most intense peaks in the mass spectrum is called base peak. The relative intensity or abundance is taken as 100, and then intensities of the other peaks, including parent peaks, are expressed as percentage of parent peak. Some important self-understanding questions are mentioned here. What is spectrum, parent ion or parent atom, and important features of the parent ion: nitrogen group, McLafferty rearrangement, metastable ions peaks, metastable peaks, fragmentations method, retro disorder reaction, and important features or salient features of mass spectrum of different functional groups are mentioned. Thank you one and all.